Hello, everyone. Welcome back to lecture number 4. This will be the last lecture of part 1. After finishing this part, we're going to move to part 2, which discuss about bias in general and how to detect bias in research. And then later on, we'll discuss in part 3 conceptualizations of research and research methodology. So this lecture today, number 4, will focus on cognitive bias and why cognitive bias are important. So our mind has the capacity for being reasonable, has the capacity for being rational, to be conscious about our faults, about our mistakes. It has the capacity to think logically in a reasonable way. But at the same time, our mind also has the capacity to be egocentric, meaning that sometimes we're not aware about our own mistakes. Sometimes we become unconscious. Sometimes we have no self-serving perspective. So really, if we leave it to ourselves, our thinking sometimes is often biased, and that is another reason to have a peer review in science. If you leave it to ourselves, sometimes we have distorted conclusions, ill-founded or prejudiced conclusions. And also don't forget that our thinking process, our mind, is very influenced by our emotions, feelings, and things that we desire, or things that we want. So egocentric self-deception is so good at seeing the world as we wish in order for our mind to get what we want and to protect our belief system. So many individuals would rather believe the conclusion is true because we hope that the conclusion is true, or we feel that, or we wish that the conclusion is true. And for example, when we're dealing with COVID-19 and we're doing a study on, let's say, hydroxychloroquine reported on 7 patients who got better, we hope that the drug work. So then we might end up having a conclusion that this drug works, although the sample size is too small and the study is not really a good study. So sometimes because of our feelings, because of our emotions, we tend to think about the conclusion in a different way because of this self-deception. Also, don't forget that language has effect on our thinking and cognitive ability. That is the reason why in advertisement, people know this and they know how language can affect us. So they use words in advertisement. For example, when they put names for fabric softener, they call them comfort and not rough, because these words influence us somehow. If you're buying a low-fat milk, the 2% maybe could represent 2% of weight rather than calories, where if you calculate the calories, for example, it might be much higher, to like 31%. You will hear things like freshly squeezed orange juice. Fresh orange juice is different from freshly squeezed orange juice. It gives you more, these words gives you more power and they influence you somehow. As we gave an example before in the previous lectures of the battery that lasts up to 8 times longer. Again, meaningless comparison. Longer than what? We don't know. Up to 8 times also is not accurate estimation. So what do you mean by up to 8 times? It could be 7 or 6 or 5, etc. So when you're seeing an advertisement for toothpaste, for example, then you often hear that 4 out of 5 dentists recommend this toothpaste, for example, over other brands. Who are these dentists? Recommend for what exactly? It's helpful for what exactly? So it is not clear, but the language influences so many times in many different aspects in our life. And you can think of multiple other examples for yourself. Unfortunately, human errors are very common, and it may occur at different stages when you're doing an experiment or observation. It could lead to faulty perception. It might affect the processing of information through cognitive biases, which we will discuss about also in the next few slides, or recall bias. So sometimes we have faulty memory. Our memory tends to forget as human beings, and that might distort the reality. So there's several ways we can develop error because of our mind. And cognitive biases, there are several cognitive principles which might lead to false beliefs. So meaning that we will conclude something is right, but it is wrong. And this conclusion happened because of some sort of cognitive bias, the way of thinking, the way that we think led to a false conclusion. One thing that might lead to this is pattern recognition. So our mind is so good at seeing regularity and patterns in random things. So we like to, our brain has evolved to like patterns and regularity. Our mind is not used to see random events. And even if we see random events, we tend to try to think about any possible way to make it regular. So if you're unable to detect or correct the biases due to incomplete or unrepresentative data, your mind will try to make it in templates of regularity. In other words, it is exhausting for our mind to see irregularities or random events. So if you're dealing with ambiguous data or incomplete data or unrepresentative data, our mind has a tendency to interpret these data in light of our prior experience or prior theories, what we say a priori expectation. So this is a form of cognitive bias that we have to consider. As we said, our brains have evolved to be really good at coincidence detection and pattern recognition. And we are good at this. Why? Because we want to make sense out of random, unconnected data and to see patterns and correlation that are sometimes are not there. So we will make up some correlations so that our mind become at peace. And give you an example, if you have a coin and you toss that coin, let's say 5 times, and if you're doing that 5 times, you'd expect to see some turns where it be heads and sometimes it be tails. However, if you do that 5 times and in all those 5 times the coin turned to heads, somehow your brain will immediately think that there's something wrong. There's something not random. If 5 times it happens to be heads by chance, by coincidence, our mind will not like that. It will immediately think that there's something non-random happening. Also, it's very common that people mistake correlation for causation. correlation does not equal causation, and maybe we'll get another chance later on in future lectures to discuss the difference between correlation and causation. But this is also another common cognitive mistake that people make. We also have things called heuristic biases. So this is a form of cognitive bias where we tend to put judgment under conditions of uncertainty in a very fast way, quick way. So in other words, I call them shortcuts. So we tend to make judgment and inferences that we put very quickly on certain things just because we are not certain about the data. Why our mind does that? Because it is very quick, it's economical on time. Yeah. It is exhausting for our brain to think about all the different possibilities and to try to analyze things in details. So it is easier to make shortcuts and basically judge the data or make quick inferences or extrapolate or assume certain conclusions. Okay. Also, we tend to give too much weight to evidence which supports our belief while we ignore evidence that contradicts it. This is another form of cognitive bias that we need to be aware of. As Thomas Gilovich says, people are inclined to see what they expect to see and conclude what they expect to conclude. Here's an example of how cognitive bias can occur. This is an exercise that was made by a person called Watson. It's called Watson card problem. You can learn about it online if you're interested. But basically, here you have 4 cards. There is a letter on one side and a number on the other side. And the question here is if a card has a vowel letter on one side, then it must have, or it has an even number on the other side. So the question is, what are the cards that you need to turn to falsify this statement? The statement that says, if a card has a vowel on one side, then it has an even number on the other side. So you can take a minute to think about this exercise, then we can talk about what kind of cognitive bias happens when we think about this example. Okay, so if you choose A and 7, that will be the correct answers. So the 2 cards, A and 7. If you choose A and 4, this is actually, this Watson card problem has been studied, and it's been shown that the most common wrong answer is A and 4, choosing 2 cards, A and 4. Why is this? Is because of something called confirmation bias. Well, our brain wants to confirm, since we know that 4 is an even number, wants to confirm that A and 4 actually follows each other. However, if you turn 4 and it is a vowel letter, it will not help you to falsify your belief. In other words, it will only confirm your belief that what's behind 4 is a vowel letter. However, you want to falsify the statement. That's what the question is about. And that's what modern science is all about. Please remember, we have talked about falsifiability multiple times. Modern science based on falsifying a theory. Okay, so confirmation bias is a form of cognitive bias that we sometimes make to conclude false conclusions. Okay. So moving to next slide. Uh, So as we talked about falsifiability, the best way to confirm a hypothesis is to attempt to disconfirm the hypothesis. Okay, a theory is scientific only if it is refutable, if it is falsifiable, and we have talked about this in last lecture in details. Okay, so researchers find subjects usually to try to confirm their hypothesis rather than disconfirm it, and we should do the opposite. We should try our best to disconfirm our theory rather than to confirm it, because you cannot confirm any theory, as we discussed before. Uh, why we're doing that? Because cognitively, a form of cognitive bias that we want to confirm our belief, and we tend to ignore what contradicts our belief. Okay, so this is a form of cognitive bias that we should get rid of. So to summarize this part, part one, from all the different lectures that we learned so far, today's lecture was a short one, but to summarize what we have learned so far, we talked about truth and knowledge and how can we reach to the truth. And we said that there are different systems or paths that you can use to reach the truth. And we discussed an examples of induction, deduction, and religion. And we talked about how modern science actually depends on induction. In other words, empiricism or empirical evidence. We also discussed that modern science is not perfect. We know this because of several limitations of induction that we talked about in the previous lectures. Claims can be critically appraised through different tools. The one that we discussed was called filters, and it is a nice way to try to refute and critically appraise scientific claims. And last but not least, we also talked about cognitive bias and how important cognitive bias are, and we need to be aware that they exist. And there's so many articles published on this, and so much research is going on and have been already conducted on this in psychology and other branches. So it's something that is there and we need to be aware of. So thank you for seeing and watching these lectures. I hope to see you soon in the second part where we will discuss about the different kind of biases and how to look for them and how to identify them. So we'll see you soon. Thank you very much.